Good morning, SymphonyCon, and happy Friday. We hope you had a great time yesterday and a fun time at the park as well. So we are really excited today with Leah to be sharing the stage and talk about a topic that has not been addressed yet at SymphonyCon, which is the relationship between the web industry, cloud, and climate change. But before we do that, we want to introduce ourselves. And so my name is Fred Plais. I'm the CEO and co-founder of Platform.sh. I am a serial tech entrepreneur. I've been building digital products and services since 2000. I'm also a French citizen living in the US. I live in Los Angeles. And I'm passionate about climate change. It's been part of my conversations for a long time with friends, families. I've been documenting myself quite intensively recently as well. However, I'm no climate expert, which is why I'm really excited to share the stage with Leah Goldfarb here today. And I'll let Leah introduce herself as well.
Thank you, Fred, for that introduction. Hello, SymphonyCon. So I'm also very excited to be here today. I became interested in environmental issues at a very young age. When I was a little girl, my family evacuated for the 3 Mile Island nuclear power accident, and it set me on this path to understand environmental problems from a scientific perspective. I started my PhD work looking at the ozone hole, and I finished it looking at climate change. But very quickly, I realized that the science around climate change was settled, and that what we needed was action. So I spent 20 years in the science policy arena working on environmental issues generally. And when I saw the opportunity to take the recommendations from the scientific community and put them in action at scale in the tech community, I jumped at the opportunity and became Platform.sh's Environmental Impact Officer. And I mirror Fred by being a US citizen living in France.
Thank you, Leah, and we're grateful to have you. So we thought we would start this presentation with what we believe is an inspiring and a beautiful story, which happens in the rainforest. There's a huge fire out there, and all the animals are leaving the forest. And there's this little hummingbird, colibri in French, which actually is running towards the flames. And the animals are saying, hummingbird, what the hell are you doing? Well, I'm trying to put out the fire. But how are you going to do that? Well, I take some water in my beak, and I'm going to put the water on the flames. And the animals are laughing at the hummingbird, thinking, this is crazy, this is meaningless. And well, it can feel fairly meaningless from time to time to try and take action on the environment. You feel that you get very little action power to do so, but actually at the end of the day, we believe that there's action we can take that are meaningful and that can have an impact. And so that's why we want to try and tell you today. And so since we know that you fine folks in this room are not so much about tales, but very much about data and numbers, we want to share numbers with you and try and make the point that yes, we can have an impact, we can take action that are actually meaningful, and with our industry, with the community, working together, we can make a difference.
All right, so I know about climate change, but I don't know about PHP and Symfony as well as you do. So you were kind enough to come here today to listen about climate change, so I thought I could make an effort and talk to you a little bit about some quick calculations that we tried with PHP. So if we ask people in the room here to think about what could be the carbon impact of PHP in the world. Now, as you don't think about carbon from day to day and its emissions, I'll give you a little bit, a ballpark number to think about. So France's CO2 emissions per year are around 300 megatons. So 10 to the 6, a million tons of CO2 put into the atmosphere per year. Do you think that the emissions that could be associated with PHP are equal to, greater than, or less than that of France? So I'll just let you think about that for a minute. And then try to think about what type of impacts could a community like this make to reduce whatever emissions are associated with the cloud emissions from coding. And think about maybe an update to PHP. Could that make a difference in emissions? Could we reduce something? Okay, let's pick another European country, a little bit smaller than France, to think about, could it be equal to Austria's emissions, which are around 65 megatons CO2 per year? All right, so now we're going to do some speculation. We're going to start out with numbers that we know about, and then we're going to have to guesstimate for the rest of the calculation. So globally, CO2 emissions are around 40 gigatons, or 400,000 megatons per year. And we know that the ICT, the Information Communication Technology community, community releases 4% of all greenhouse gases. So that's everything. That's cloud, that's making cell phones, computers, the network, everything, okay? And that 4% is about the same amount as the aviation impact. So it's large, and we can have an impact if we act. Okay. Then this is where we really have to do some back-of-the-envelope calculations. This is obviously not peer-reviewed literature here. If we say that the impact of the cloud and websites have an impact of maybe 25% of that 4%, and we know that PHP powers around 77% of websites, and that the small print here is count, not volume. So I just want to be clear here, because I wasn't able to find the volume numbers, and if anyone has that, please come talk to me afterwards. Multiply that all together, and we come up about 300 megatons CO2. So just a quick estimate is, the impact of our web communications is large, but the good news is we can act. So now let's do a similar type of calculation using the number we just used to think about an update from 7.4 to 8.1. So there's the number we just used, we calculated. Now if we think about that update, we know it's about 30% faster, and it uses less electricity. That's our assumption here. And then we may use a conversion factor from fewer resources to the amount of CO2 released. And this is a number that comes from our carbon audit, which was performed by Greenly. And we get to the 67 megatons CO2 potentially averted from that update. So now back to the slide that I showed at the beginning. So potentially, the impact could be very large about just updating your software. And again, a disclaimer at the bottom, if this is even too large by an order of magnitude, it is significant. So why stop with PHP? Let's think about also updating Symfony. As Symfony runs 5 to 10% of websites, and if you're running, let's say, 4.4 or 5.4, just updating to 6.0 would already get rid of the legacy code and make not only your applications faster, but use fewer resources, use less electricity, and emit less carbon. And let's see. So I guess the visual image I'd like to leave you with is that one developer making this change can then discuss with 2 more developers who can then, geometrically increase the impact of saying, hey, I'm updating, and I'm doing this to have faster apps and to take action on climate. We could even imagine a working group around environmental issues. In the open source community, they're already starting to form, maybe in Symfony. There could be even a hashtag that could trend saying why you're doing that for acting on behalf of the climate. And we could knock down CO2 emissions by doing that. Okay, so now that was just a teaser about how this relates to this community. Now, I've been talking a lot about climate change, but I haven't really explained what it is. We all have like the vague ideas of what's going on, but let's just go through it so we're all clear. So climatologists think on geological timescales, if possible. We need at least 30 years before we really discuss anything. And if we can have a timescale that's even longer, 800,000 years, all the better. So what we have here is a profile of CO2 going back in time. And this is CO2 in parts per million, so a trace gas in our atmosphere. And you can see this up and down cyclic path that CO2 has taken over time. And then, of course, the large spike. To not complicate this graph, I haven't overlaid temperature, but it tracks with CO2. So what we're seeing here are glacial periods and interglacial periods. And the difference from the top of the curve to the bottom part of the curve is about 5 degrees Celsius. This little area here is the Holocene. This is where agriculture has been established in the last 11,000 years. This is where our culture has been established, our cities, our infrastructures. And this is what's happening now. So CO2 has increased in our atmosphere by 50% compared to pre-industrial times. So the rate of change that we're seeing here is not been seen in the past. We're in a non-analogous state here. And so now this difference in temperature we're seeing, in CO2, we're seeing going in the opposite direction. And that is raising the temperature of the planet. Globally, we're between 1.1 and 1.2 degrees Celsius, which is about 3.6 degrees Fahrenheit. All right, so before we even tell you about climate change, we first have to just take one step back and think about what is the greenhouse effect? Because the greenhouse effect is actually really positive. It's what prevents our planet from being an ice ball. So the sun radiates in the ultraviolet and the visible. It hits the planet. The planet absorbs that energy and radiates back in the infrared. And this very thin layer of atmosphere that contains greenhouse gases is what creates this Goldilocks environment that we all live in. What happens when we start to burn fossil fuels and emit more CO2 into this atmosphere is we thicken that layer. You can think of it in that way. It's like putting an extra blanket, putting an extra coat, and they just keep coming and coming and coming. And that's what's creating this increase in temperature in our atmosphere. All right, so we're meeting here, not that far from where the Paris Agreement was negotiated, about 30 kilometers from here. And this has been a historic agreement that happened at the COP21. The COP27 is scheduled to finish today. And what they agreed there, the countries of the world, was we must limit the warming of our planet by 2 degrees Celsius and make every effort to keep it to 1.5. And the reference year for this is compared to pre-industrial levels. This was a real change in the climate negotiations compared to what had happened in Kyoto, where we had developed countries saying they were going to reduce by a certain percentage, and developing countries said, no, we need to develop. So what happened in Paris was all the countries said, this is what we agreed to. We're going to do this. And then they let the different countries decide their nationally determined contributions. And that was the legislation and the commitments that each country was going to take. And for France, they negotiated with the European Union. Now, if we look at what's really happening today, the policies that are on the books do not meet what the government said they were going to meet. So we're currently looking at a 2.7 degree warming if current policies are put into practice. Pledges that have been coming in by countries say if all of the proposed legislation is enacted completely, by 2030, we should be able to keep warming to 2 degrees. And the IPCC tells us that really we need to be at 1.5. So this is where we are today, and this is why we see countries starting to act, pass laws. In Europe, for example, the Green Deal was passed in 2019, saying they were going to reduce greenhouse gases by 40%. That they said they were going to reduce by 40% at Paris, and then when the Green Deal passed in 2019, they said, no, we're going to now reduce that by 55% by 2030. So this is the way someone who studies climate thinks about economics. We think about it in the long term. So what we have here in the green is if we act on climate versus inaction. And then we look out to the end of this century, 2100, and in red is 2200. And the orange column is how much it will cost us by the end of the century to act on this is to act on climate and the climate damages. So this is just in terms of dollars, just dollars. It doesn't talk about the real life impacts of climate change. This year we saw Pakistan have tremendous flooding. 1/3 of the country was underwater. So it has real world impacts on humans, ecosystems, and this is just the financial component. So it'll take about 2 trillion euros to really act on climate per year, but the damages are going to be substantial. And because of the lifetime of greenhouse gases in our atmosphere, it's going to have long-term effects. That's why we talk about it being an intergenerational problem. But the good news here is that it's going to be cheaper to act now on climate than to wait to act on climate. And when we start looking at the possibility of a world by 2200 with $70 trillion of damages, this is an uninsurable world. This is a world that looks nothing like the world we have today. So the way I see it is that for a very little investment, we can avoid so much pain and suffering, even by the end of this century for the next generation. And I imagine that there are some young developers here who will be here at the end of this century. All right, so now on to the good news. So a lot has happened in the last 10 years, and the tech community has a lot to be proud of here. They have massively invested in renewables, and this has brought down the price of renewables such as solar and onshore wind here in the past 10 years, making it cheaper than any fossil fuels. So this is going to start to be deployed at scale. This is what Al Gore spoke about at the COP 27. He said, you know, we were entering into the sustainability revolution, and it's going to happen at the scale of the industrial revolution, but at the speed of the digital revolution. And with that, I'll pass over to Fred.
You get 2 more slides.
Oh, yeah. Oh, sorry. Okay. Yeah. So very quickly on the role of the IT community. Well, so at the beginning, not too fast. Okay, I said that the 4% of greenhouse gases are coming from the IT. This is the study that it came on. And we're at an inflection point here. If we go out to 2040, we can be on a curve that sets us, this is the business as usual. This is the curve that we're on right now that will be up to 15% of greenhouse gases will come from the ICT community. But if we make choices today, we can mitigate the amount of greenhouse gases we put into the atmosphere and hopefully even bring it down lower than the 7%. Okay, so in general, as we talk about carbon cloud computing and taking carbon audits, it's important to define our scopes. And what we do is we follow the international protocol on how to calculate carbon in the cloud. And our scopes are the data centers and the network. We do not count the devices in your hand, which are very important, but that's not lost either. The carbon cloud calculations for cellular phone manufacturers, computers, that's in their scope. In our scope, it is the data centers and the network. And the data centers, we do take a lifetime assessment of the manufacture and the use of these data centers. And for the network, we model it, and as we'll discuss here, the modeling here has been changed over time. And so we keep up with the literature with that.
Thank you, Leah. And so let's get down the layer and see what can be done at a cloud platform level, like Platform.sh. So, at our level, at Platform.sh, we've said for years that climate is not an afterthought. And in April 21, we decided to sign the Climate Act, which committed the company to do carbon audits and cut emissions by 50% by 2030. We also started to communicate on the fact you don't necessarily need that extra server. We think that doing a fair use, a good use of resources is very important. And in the industry, we have had the tendency of throwing metal at software problems a bit too much. We think this is a behavior that can be corrected and should be corrected. We can do better and smarter. And we've been thinking about trying to take action by putting together a framework, which we call the mode framework, which is the way we try and collaborate with our customers. I want to stress that this is really a joint effort between ourselves and the customer, and it really works if both parties are actually willing to take action. And so what do we do? Mode stands for 4 letters. It's measure, it's optimize, it's deploy, and it's educate. So let's start with measure. I've been too fast. Measure, and what you cannot measure, you cannot improve. So we started with a carbon audit, which, as you can see on the numbers, so we've done that with a third party called Greener. We've used the greenhouse protocol, greenhouse gas protocol. And what comes out very clearly on that chart here is that scope 1 and scope 2 for a company like Platform.sh, we have 390 employees today. Everybody's working from home. As you can see, scope 1 and scope 2 is ridiculously low. It's very low because we don't commute to the office. We don't have an office. We've got a very small one. We are paperless, so scope 1 and scope 2, that's not the issue. Scope 3 is the issue. And what is scope 3? Scope 3 is the cloud resources we actually use to serve our customers. Those 4,000 tons in 2020, which has grown tremendously since then because we're growing fast. So this is where we want to focus our attention, the 4,000 tons. And as I said, we think about optimizing in 2 ways. We think there's 2 things we can optimize. First, the cloud density. So it's our job to actually make the cloud platform as dense as possible so our customers can run on as little hardware as we can possibly do. And also about the code. And the code, making sure that the code is optimized is a very important aspect of it as well. And for that as well, we have our customers' backs, because we are providing them tools to do that better. So let's start with density. What the carbon audit has shown is today, on average, the platform is 12 times more dense than if you're running on dedicated hardware. And we looked at the comparison precisely with AWS EC2. So we compared our cloud platform versus running on EC2 machines. And it's precisely 12 times, so 10 times more on production, 14 times more on development. And this comes from the fact that we mutualize our servers among customers. We duplicate storage as much as we can. We run very little containers. We make sure that every server is used at 95%. While if you're running dedicated servers, you probably don't do that because you want to make sure that you absorb peaks. So all of this together makes a huge difference, on average 12 times. We also want to make sure that you're going to optimize your code, and this is not our code. We're not writing the code for our customers. Our customers actually, and our agencies, partners, are actually writing the code. So how do we do that? We can help on that. And we help through a tool, which is a company that actually we acquired like 1.5 years ago, which is well known in the Symfony community because it was built by Fabien, who's now, we're very humble. We have Fabien in the team, and it's an amazing journey for us to have Fabien in the team as the Chief Product Officer. But what Blackfire provides is, what Blackfire does first is, first it measures the load time of your code, identify the bottlenecks, and 3, it gives recommendation on how to improve. So this makes a lot of sense to improve the quality of the code, but also the speed of the code. Just as an example, one of our customers, GOG.com, which is a leading game provider, managed to increase their performance by 20 times. So they can actually do 20 times more recurring orders at the checkout level, just improving their code. No more hardware, no additional hardware, just improving their code, 20 times more orders. So that's a massive number. And this is the sort of things you can do, which is actually good for your site, good for the climate, good for everybody. So again, why is that good? It's good because if you use less servers, you use less electricity, and less electricity means less carbon. So of course, this is the mechanism that applies on both more density and also on better code. But that's not the only one. So we, on mode, the D stands for deploy. And here as well, that's interesting to see that there's a lot of lever on where you're going to deploy your code. So as you can tell here, this is a map of Europe. And what green means is clean energy, in a way. This is measured by the carbon per kilowatt hour. So the tons of carbon in time that are actually generated. This is open data. This comes from electricity map. So this is actually an amazing site. If you haven't visited, I suggest you should. This actually updates every hour. You see the quality of the grid for every country. And so we've taken averages at Platform.sh, and actually the place where the data center itself is located matters a lot in terms of carbon emissions. If we take a couple of examples here, you can see that France is green. France, as we all know here in this room, is very nuclear-based. Nuclear is actually clean in terms of carbon. We can see that Norway or Sweden are actually also very green. They use a lot of hydraulic energy and also wind, very clean. So if you're running your software in one of the regions here, if the data centers are located on one of those regions, or if you're running it in Poland, which you can tell is very brown here, it's based on gas and coal mostly, that's massive. That's a massive difference. It's a 1 to 10, up to 1 to 10 difference. So look at where your data centers are located, because the electric grid that they are inserted in will actually make a huge difference in terms of your carbon footprint. Same thing applies to North America. And if you're thinking, okay, my audience is actually on the West Coast, or my audience is on the East Coast, well, choose Washington State rather than Arizona for the West Coast, and Quebec instead of Florida or Kansas. Same difference, massive difference, 1 to 10 sometimes, 1 to 6 very often. So this makes a huge, huge difference. And at Platform.sh, we're trying to also help our customers decide the regions they want to run on. Of course, you want to take a criteria of where is the population that I'm trying to address with my website into account, of course, because you don't want to be using the data center in Sweden if you are running if your customer base is in Australia. That would make absolutely no sense. But still, what we learned, and we'll see that on the next slide, is that the transfer is not the main, is an important aspect, but not the main aspect. The cloud origin is very important as well. And so what you can see, making your choice for a region where you want to run, we're going to provide you the average gram per kilowatt hour per the grid around your data center. And that's an interesting criteria, a criteria mostly none is actually using today. Most people actually just pick a cloud platform, thinking Azure, a country where their population is located, but not thinking about carbon emissions, where it can make a tremendous difference. So I encourage you to take a look at that criteria as well to make your decisions. E stands for educate. One interesting aspect is, this is a learning process. It has been for us, certainly. But really what we realized is carbon auditing is still in infancy. We are learning and actually discovering that wrong assumptions were made in the past. For instance, here, we realized that the transfer that we thought was 72% of the total emissions are actually only 54%. Still big, more than 50%, but 54%. And so we had to revisit our audits. So just out of transparency, this is a learning process, and we're trying to update and keep up to date with the latest data available. So again, three levers that work as a partnership with our customers. First, the cloud computing density. That's something that you can get with providers that you can actually do yourself as well. And more density is, of course, the first level that we all have in our hands to improve our performance. The second is, please use an APM. Blackfire is great. There's other options. In any case, making sure that your code is actually running fast is very important. Again, we can't keep with the habit of throwing metal problems. Just compensating bad code with more hardware. That's the solution of the past. It can't be the solution of today anymore. And also, please think about where you're going to deploy. What is the right location for your software to run? This has tremendous impact, sometimes up to 15 times. And look at those numbers, just 1 second. We're not talking of 5% decrease here, or 10% decrease. We're talking of divided by 5, divided by 10, the carbon emissions. So this can be very meaningful, and we can act today. We can act today. And it's already the time for conclusions, actually. So if there's a couple of takeaways we'd love for you to leave the room with. First is, as Leah really clearly pointed out, climate change is happening now. The more we wait, the more disastrous it's going to be. So we need to act now. And good news is there are solutions. There are things we can do today that can make a difference. For instance, update PHP. PHP, we saw that just updating your software, and in this room, I'm sure that probably everybody has done that already. You guys are very savvy on those technologies. And if you didn't do that for climate change, you probably did that for security reasons. You probably did that for code quality reasons, or just like running on the latest and the best software version. Same for Symfony. But don't just do it. Please educate around yourself. Educate the younger developers. Tell your boss that actually it has an impact as well on climate change. Educate your boss. We need to spread the word that things can be done. Use an APM. Move project to greener regions. This is win-win. This will result in faster apps, a better customer experience. This will result in a reduction in greenhouse emissions. And if you like this session, please follow up with us in the Platform.sh room on the other side of the conference. Leah and Marie from our data team are going to explain how they are making those math, making the calculation work, calculating what they can see. What you can see is CO2 here in, no secret. This is going to be the topic. And it's happening in 10 minutes in the Platform.sh room. Thank you very much for your kind attention.